Hello, guys. Welcome back. Or if it's your first time, still welcome. We have today Leetcode 207 course schedule. Um, been asked by Amazon, Google, and Apple. So that seems good. Very popular question, and it's a good graphing question. So without further ado, let me read the question. Right. So there are a total of num courses. Um, courses you have to take labeled 0 to num courses minus 1. You are given an array of prerequisites where prerequisites I, A, I, B, I indicates that you must take course B, I first if you want to take course I. Yeah, okay, cool. Um, uh, for example, the pair 0 and 1 indicates I have to take course 0. If in case that you have to take course 0, actually, in the case that to take course 0, you have to take course 1. Okay, cool. So course 1 is a prerequisite of course 0. And return true if you can finish all the courses, return false otherwise. And you see that in this case, we have two courses. Um, Prerequisites you have 0 and 1. So it means to take course, as the question is saying, to take course one, you have to take course 0, right? Right. So to take course 1, you have to take course 0. So if you take course 1, there are total of two courses to take. To take course 1, you should have finished course 0, right? So you take course 0 before course 1. So 0 is the prerequisite. So that is possible. But you see, for this case, we have a cycle where you are going in an infinite loop, and I'll graph that in on the drawing board in a second. Right. So basically, it will be easier if you can see nodes. However, so let's say we have node one, right? And to take node one, you have taken 0 first, right? But here also is saying that to take 0, you have to have taken one first. So you see, we have a cycle, right? So let's say we had um so because you have the cycle, right, we can't finish because you are not able to take any course and finish the other course. Like every course is a prerequisite of another one, and you being stuck in a cycle means you are never gonna, be able to finish, right? Because it's logically impossible. Um so basically, the question kind of boils down to finding if there are cycles in your directed graph. And let's say I had three courses where I have like course 0, right? Let me give the edges. So 0, 1, right? Meaning we have to take course 0 first, right? So to take 0, you have to have taken 1. So 1 points to course 0. And then I want to say that um, you have to take cos 0 before you take cos 2, right? And basically, this is your graph. So we have a directed graph and we want to find if there's a cycle. Now, this is possible because when you take 0 before 1 and before 2, and then you're able to find if it is a direct, listen, there are no cycles. But if there is a cycle, then you can complete the courses. Um, so basically, what we want to use to solve this problem is topological sorting. So topological sorting is such that like you have a directed graph. Hopefully, it's a directed acyclic graph, and then you take the element with the least number of the 0 in degrees. So once you pop it out, right? Um, so once you pop out the element with the in degree, you process it and you let it, you do whatever you need to do on that, and then you keep going, you keep going. So now if you're able to go through the whole every single element, you're processing every element, right? Then you know for sure that there's no cycle. But once you're unable to process all the elements, topological sorting style, then which is Kahn's algorithm, then it shows that there is a cycle, right? So for this example, the in degrees, and I want to keep the in degrees. The in degree of 0, there's nothing pointing to 0. Sorry, pointing to 1. So the in degrees of 1 is what 0, right? So it has a 0 in degrees here, but 0 has 1 pointing to it. So it has one in degree of 1, and here it has another in degree of 1, right? Lorem 2 has an in degree of 1. So when we take 0, we'll process. So we take 1, we are going to process because it has an in degree of 0, right? So we're processing node 1. Then we come, and now node one doesn't depend on, sorry, node zero does not depend on node one anymore. So what happens? The integer of zero now becomes what? Zero, and then we process this guy too, and then that cuts this connection. So this whole guy also becomes zero, right? So in the end, we process node one, process node zero, and then we process node two, basically. And if you're able to do so, right, then we know that what it is. It is acyclic, right? There's no cycle. However, and then we'll be able to say, okay, true. There's a way we can like find. There's a way we can take the courses such that like we are going to go through each course. Right? But like if there is a cycle, like let's say you have node one and node one points to two, right? So sorry, node zero points to two, and two points to node one, right? And node one again points to zero, right? You can see this is a cycle. You can go infinitely. So initially, let's use topological sorting to find the in degrees. Right? This guy zero has one in degree. He also has one. He also has one. So in the end, we never really start with our BFS because we have no element with what an in degree of zero to even process in the first place. So we know for sure that there is a cycle, right? So basically, you only use topological sorting to find um, if there is a cycle or not. And let's just jump into it because it should be not crazy if you know Kahn's algorithm. And I hope maybe this explanation has been helpful with that regard. So basically, your NAM courses, right? You have NAM courses, um, and then your prerequisites. So I want to build a graph, right? So a graph of the edges. So an adjacency list basically, and I call it AG, and then it's an array list, right? And I also want to keep the in degrees, right? So in degrees is equal to int, and it's going to be now quarters long, right? So initially the in degrees are all zeros, and then I want to build that graph, right? So I want to build a graph. So we are going to look through prerequisites, right? And actually, before we do that, let's look through courses, right? Every possible node, and then set its element. Actually, this should be courses length. Every element at its index to what an empty array, right? So A G K, and then set a new array list in its place, right? So we are building our graph initially, and then we go through prerequisites, right? So I'm calling tree of prerequisites. So who is the source node, right? Like basically, if you have 0, 1, it means you have to have taken 0, and that 0 is going to point to 1, right? So say int u should be the first element, right? And int v should be the second element. Right, so who is being pointed at here? Well, 0 points at what? 1, right? Because let me just read the question again, not so to be confused, but it says you are given an array of prerequisites where A, I, B, I indicates that B, you must take cos B, I. Hey, sorry, indicates that you must take cos B, I first if you want to take AI, right? So B, I is going to point to AI, right? So AI is going to have an in degree increasing at least by 1, right? So our AI here is our U. So in degrees of U will increase by what? 1, right? And then in our adjacency list, basically, we say that we have V, right? And then we add the node U. So basically, um, the nodes that are connected to V, right? We're going to add their neighbors here. Okay, cool. And now after that, you just use a queue. For the queue, use a linked list, and then we add elements with in degrees, right? being equal to 0, right? The nodes whose in degrees are 0. So in degrees of length, and then k plus plus, right? So now if the in degrees of k is equal to 0, right, then we should add it to our q. So our q add um, this, and then while our q is not empty, right, we take an element to call a current is q dot pull. Right, we remove that element, right, from our list, and then we go to all its neighbors and reduce their in degrees by 1, because now we've removed one element that depends on them. Right? So int neighbor in what a map, so ag current, right? What we want to do is go there, and then the in degrees of the neighbor we decrease it by 1, right? Now, if the in degrees of the neighbor now equals 0, right, then it's fit enough for us to add it to our queue. Right? So I'm going to add neighbor to our queue, and hopefully this one keeps going on and on and on and on. Now, one way we can see if we've processed every element is to loop through what are in degrees, right? Loop through our in degrees, and then see if every element has an in degree of 0. That means it has been processed. However, one other way I want to do it is actually to keep a count of the process nodes, and I'll call it counter, right? And then we use it whenever we add an element to our queue, right? Whenever we add an element to our queue, we increase the counter, so that we can use that and check if the counter is equal to num courses. That means if it is, right, if the counter is equal to our number of courses, it means we process every node, right? So we return true, else we return false, right? Maybe there's a cycle or something like that. Cool. So counter 0. That should be fine now. Right, so we pass the first two cases. Let's see. And then we pass 75% of other Java users. So basically, it's just topological sorting, a very easy question. If you know Kahn's algorithm, right? So the question now is, what's the runtime? That's a good question to ask. And the runtime, you see, we have O of n operation here, O of n operation here, right? We're going through the prerequisites array, and also O of n operations here. In the worst case, same here. So overall, it's going to be O of 4n or O of n, right? So that's going to be your runtime. So if I hope this video was helpful. I like Kahn's topological sorting, and I think it's a very good video to make. Um, if you like it, guys, like and subscribe. I'll see you on the next one. Take care.